Hello friend, I'm Samadhi back to a new tutorial video regarding IS456-2000. So last two video I talk about the 35, that is safety and serviceability. Then next video I talk with about the characteristic and design value of the purchase safety factor. In case you missed it, then there's some I button, just go and check out. And without further delay, let's get started today's discussion about this analysis part. How should we do the analysis? Before starting this analysis, first I am talking about this table number 18. What, what is the different types of partial safety factor and when we use these particular value. Okay, so first I will dictate what is written here. Then I talk about when we should use this. First I want to say DL, that is your dead load. IL, that is imposed load, you can say it is life load. WL, that is wind load. Okay, wind load, you often ask me why there is no earthquake load. Actual, if you use wind load, then you didn't use the earthquake load. If you use the earthquake load, you don't use the WL, I mean to say wind load. You at a time you use only one load between wind load and uh, earthquake load. So better to say wind load or earthquake load. Okay. So DL, IL, that is the live load, imposed load, and it is WL or E. So basically, there's two types of limit state. First is limit state of collapse, and second limit state of serviceability. So basically, we do the limit state and we check for collapse and check for serviceability. If both scenario the structure is safe, then okay, fine, we can go ahead. Otherwise, we go for the redesign. So there is some three conditions. Number one, dead load, live load. Number two, dead load plus wind load. Number three, dead load, imposed load, I mean to say live load, and WL. When we use the first combination for limit state of collapse, DL plus IL, that is 1.5, and for serviceability 1.0, no multiplication factor. When we use dead load and wind load, that is both 1.5 and 1.5, a special condition there is a 0.9. And when you use the three load condition, DL plus IL plus wind load, that is the 1.2, and for serviceability 1.0, 0.8 and 0.8. Why 0.8, 0.8? Serviceability means we are using the structure. So when we create a structure, we can take the maximum load. But when we use a structure, it is not necessarily like that. The structure has its full load. That is why imposed load is 0.8 and wind load 0.8. I give you an example. Suppose you design a building. So maximum live load is for 10 people, suppose 7 Newton per m. Wind load maximum is say 10 Newton. The high wind is blowing. But when you start living in this room, say there are only 4 people. If there is a 4 people, you just tell me, is it 7 is working? 7 Newton per mm? No. It must be less than 7. I mean to say 7. And if suppose this is the normal season, like normal, it's not the high wind blow season, then for normal wind it should be the value of wind load less than 10. That is why limit of serviceability 0.8, 0.8. But why dead load 1.0? Because there is structure. So for structure, it is using its whole load, that is the DL. So that is the combination, load combination. So how I find the maximum? So basically when you have the load various types of, so you find condition 1. Suppose this some using your load, it's come the 230. DL plus W, it's come say 200, and this come 250. So you design for 250. So your limit state collapse should be 250. And from this value, say it's come 100, this come 90, and this come 85. Then for limit state of serviceability, we take this maximum value, that's 100. So in this fashion, we will take the highest value for designing the building. I hope that is clear. Okay, if not clear, so do comment in comment section. I will definitely get back to you. Method of analysis as in 22 shall be used. The material strength to be assumed shall be characteristic value in the determination of elastic property of member irrespective of limit state being considered. Redistribution of the calculated moment may be made given in 37.1.1. What is the redistribution of the calculated moment? Redistribution means, say, this is your joint, beam column joint, and here the load is coming, acting. Okay, if load is acting here, then what happen? Moment generated, moment will generate. If moment is generated, then one part of moment comes here and one more moment come here, because as per moment distribution law. So that is why they are saying that redistribution of calculated moments may be made in 37.1.1. What they say? Redistribution of moment in continuous beam and frame. The redistribution of moment may be carried out satisfying the following condition. Equilibrium between the internal forces and the external load is maintained. The ultimate moment of resistance provided at any section of a member is not less than 70% of the moment at the section obtained from the elastic maximum moment diagram. The ultimate moment of resistance provided at any section member not less than 70% moment at a section obtained from elastic maximum moment diagram. Elastic maximum moment diagram means BMD. Not that less than 70%, because 30% should be redistributed in other section. The elastic moment at any section in a member due to a particular combination of load shall not reduced by more than 30%. More than 30%. That means suppose here 100 Newton meter is coming, then 30% comes here and 70% are staying here. So that is not less than, not more than 30% and not less than 70% of the largest moment given anywhere by the elastic maximum moment diagram. Elastic maximum moment diagram, that means they are saying BMD. Okay, at section where the moment capacity after redistribution is less than that from the elastic maximum moment diagram, the following relationship satisfied. Suppose after redistribution, say this value will come 65. So we need to increase 5. That is why we have to calculate this. Now XU is depth of neutral axis. D is the effective depth. DM is the percentage of reduction in the moment. कितना 5% reduction हुआ. So this, if this is your cross section and this is your D by 2, your XU, depth of neutral axis, then what happened? D by 2 by D plus DM by 100 0.5. So that should be 1 by 2 plus 0.05. So that should be 0.55, and that should be less than 0.6. Okay, if this is fine, then okay. In structure in which the structural frame provide the lateral stability. In structure with the structural frame provide lateral stability, the reduction in moment allowed by the condition 37.1.1 shall be restricted to 10% for the structure over 4 story up in height. In structure in which the structural frame means it is steel structure provide in lateral stability. Then if your story is 4 story, g plus more than g plus 4, it is applicable for g plus 5, then that restricted. Previously it was 30, but now it is only 10. So remember it. Very beautiful IS codes. Just go through the IS code in this fashion. You will love with the civil engineering. Analysis of slab spanning in two directions at right angle. Analysis of slab spanning in two directions at right angle. Yield line theory or any other acceptable method may be used. Alternatively, with the provision given in the Annex D may be followed. Either we go for the yield line theory for analysis of slab, otherwise we go through the Annex D. So in next video I will talk about the limit state of collapse flexure. Okay, so today in this video I talk about how we do or how we use this table 18, how we find the maximum load, and why there is so much variation. One more thing, yeah, note, while considering the earthquake effect, substitute EL for WL. I say na, at time you use either WL, I mean wind load, otherwise you use earthquake load. The value to be considered when stability against overturning stress reversal is critical. So 0.9 is using when the stress reversal is occurred. For the limit state of subjective value, the table, okay, it's not necessary. Okay, so then we talk about the analysis of structure, then we talk about the redistribution of moment, what is the percentage, 70%, 30%, how we create the moment. Then we talk about if any case not matching with the previous criteria, then what we'll do. And then we talk about the slab. So here I end this video. So thank you for watching this video. If you have any kind of doubt, do comment in the comment section. And if you have any kind of if you feel some value from this video, then definitely must share this video. So yeah, thank you for watching this video. Meet with next week with the chapter clause number 38, limit state of collapse. Yeah, thank you.